Good afternoon. Today's lecture is about creating computational environment for this machine learning geospatial data handling. So in this lecture, first we'll see about installation of the required libraries, then the basic operations needed. So if you have to start from the scratch, in that case, you need to install the Python. So you go to Google, search for Python, and download some version of Python. Prefer uh, 3.x version of Python. Downloads Windows, and from here you can see the latest release as well as stable release. You can download some stable release package. So here you are having 3.10, 3.9, 3.11, that is pre-release. Many versions are available, you can download any version higher than 3. So 3.1, 3.2, any version will be sufficient for this exercise. So here you go and download Windows installer 64-bit, let's say 3.1 you are downloading. You go there, install Windows installer, uh, download Windows installer. So you can see it will download exe file. You install this exe file, and while installation, it will show you. So after downloading, if you click the exe file, this pop-up will open. From here you have to install. So by default, install location is this one. It installs in the user profile. You can choose the different installation location by going customize installation. Make sure you have clicked this add Python 3.10 in this case to path. This adds the Python path. Python path means location where Python is installed. That location will be added to environment variables of the system. If you are not ticking here, later on manually you need to add path of the Python folder to the system variable. You can install to some different location. Go to customize, then you tick on this pip, and all other things you may tick. So pip you ensure you have ticked, and here add Python to the path. Pip is the exe file which helps to install, which is used to install libraries, Python packages. So if you have not ticked here, later on manually you need to install the pip. So for while doing this installation, you need to be connected to internet. If you are not connected to internet, later on manual things are needed to be done. So here this one is customized path. So you, instead of installing in the user directory, you can browse, choose some different path to install. So it's your choice to install it in any customized location. So for example, I have created one folder Python 3.6 inside uh, my local disk C. So advantage is I can easily access this folder whenever needed. Otherwise, I need to go to users, the username, then local programs, Python, then I will get this. So for easy accessing the folder, then choose a different location. So after doing this, you click install. If you are logged in from the administrator, it will not ask for username and password. Here it is asking for username and password because I am logged in with user profile, which is not allowed to install. So if I will enter here admin user and password and press yes, it will install. So right now I am not installing it because I have already installed Python in my system. After doing installation, need Jupyter Notebook to be installed. Command prompt. So for command prompt, you can just press window key, type cmd, it will open, and enter it will open command prompt. Or you can use window key plus R and type here cmd, it will open command prompt. So if you have installed Python properly and you are connected to the internet and ticked add Python to the path, so if those things are done, so now if you write Python here, it should enter in Python console. Like here, I have installed Python properly. So if I am writing Python here, it will start Python executable file. Basically, it will launch the Python. So now I can perform uh, Python operations here. For example, like if I am writing a equal to b equal to 4, now a plus b, it will be equal to 6. So here Python code can be written. So, or this can work as a calculator. So you write some numbers, add them, subtract, divide. Also, some customized code can also be written here in command line. Anyway, writing uh, the code is not recommended in command prompt. It is recommended to write a script. Now we'll go to next section. Now you come back from this by writing exit and these brackets. He will come out of this um, Python to normal command prompt. Now you need to install Jupyter Notebook. So for that you write pip install Jupyter Notebook. And if you enter this, it will install, it will download and install Jupyter Notebook. So you need to be connected to the internet for this. So here you can see for most of the things it is writing requirement already satisfied because I have already installed Jupyter Notebook. So if you are doing first time installation, you will get successfully installed Jupyter Notebook, that kind of message. So after successfully installing Jupyter Notebook, in this as it is. Now we go to some folder and some folder wherever you want to keep the data related to this particular lecture. For example, my data is kept in this folder. So you will go to this folder, and here in the address bar you type cmd. It will open command prompt here. Now write Jupyter notebook and enter. So if Jupyter notebook was installed properly, it will open it. So you will get this kind of interface. You will see Jupyter is written here. Right now I have many files in this folder, so all the files are displayed. For you, these files may not be available. You may see a blank. Now what to do is go to new and click on Python 3. So here this is new notebook written untitled. I will write lab 1 here. Uh, so name is written here. Now what do you need? Some libraries are needed for machine learning applications. Since this course is focused on machine learning for Earth observation data, so we will install the libraries required for handling Earth observation data. So what do we have in Earth observation data? We have raster data and vector data. So for raster data handling, we need a library named GDAL, and for vector data handling, we need a library needed GeoPandas. Along with this, we need some library to plot, display the image, plot the graphs. So for that, a library named matplotlib is needed. Some array-based operations, since our raster image is in array format where data is stored in the form of array. So for array operations, we need a library named numpy. We may need to handle a non-spatial data or tabular data. For that, we need a library named pandas, and these are the libraries needed for pre-processing or for reading, writing of the data. For machine learning, we need a library named sklearn, and we need a library named keras for neural network based modeling. So these are the libraries, basic libraries needed. So how to install the library? So you can go to any command prompt and write pip, or let's say I want to install numpy. So pip install numpy. It will install numpy. in spelling was wrong. So here what I have got, requirement is already satisfied because I have already installed the numpy in my system. So if you have not, you do not have numpy, so in that case, it will download numpy from the internet and install. So again, I am saying for this process, you need to be connected to the internet. If you are not connected to the internet, there is offline way also to install this library. So for that, you need to go to Python repository. So Python repository is pypy.org. So if you go to that location, so all the maximum Python libraries you will find here, if not all. Search for numpy, and when you go to download, so here also it is written this is the way to install numpy. Then download pre-built libraries or wheel files also for offline installation. One source of wheel files is this one, uh, unofficial Windows binaries of Python. You can search that in Google and you will find this. Here you can search for numpy. Here is numpy. So here you can find a wheel file. Wheel file is basically pre-built file for Windows. Otherwise, if you will try to build file from the source, you need a C++ compiler in some time. So some libraries you may not be able to install from the source. For example, GDAL, if you want to install pip install GDAL, it will give error. So here you download the library corresponding to the Python version. Here it is written CP 310, which is referring to Python version 3.10. So first of all, you check which Python version you are having. So for that, if you need a library named sys, that import sys and run this by clicking here, or control plus enter, it will run. This dot version, this dot version, it will give version of the Python. For example, I am having Python 3.6, which is 64-bit. So same Python 3.6, that to 64-bit. So this one I will download for myself. Suppose you have installed Python 10 64-bit. So you will download Python 10 64-bit, and after downloading, what you will do, you go to your command prompt. For example, I have downloaded, I have kept my downloaded wheel file in downloads. So I will write cd downloads. Now I am in that folder. After that, I will write pip and full name of this wheel file. Go to the folder where you have kept the library, and full name of the uh, this wheel file need to be written, not just numpy. So for your case, this this full name need to be written here. So whatever file name is there, that you copy and paste here and enter. So it will install library from the folder. So basically, you need to download safely library from this Windows binary link and install that. After that, you install GeoPandas. Otherwise, you will get some error. To install GDAL, download GDAL from this Windows binary pack, unofficial binaries. Download GDAL and install that wheel file. Direct installation of GDAL will throw error. That's why I'm saying GDAL and Safely. These you download from there. Rest of the things you can do: pip install matplotlib, pip install pandas, pip install sklearn, pip install keras. So that you need to do in your command prompt. Here also it can do, that is not colon pip install sklearn can be written. It will install uh, sklearn library. Now you can install this before starting the exercise. So assuming that you have installed later on, now we'll proceed ahead. So as I told, we will be handling Earth observation data, which is raster data and vector data. So first of all, we'll read some raster file, TIFF file, and see how it looks. We'll plot it. Then we'll see how to write a raster file. Then we'll read some vector file. Let's see how to read a raster file. So to read a raster file, we need a library, a package named GDAL. So first of all, you need to import GDAL. We need numpy also for array operations. So for that, import numpy as np. The library is imported as np. So to access any function inside numpy, we can write np dot name of the function. So we'll see later on how that is done. Now import at lib dot pyplot as plt. After doing this, press Control and Enter. Spelling mistake. So if you are not getting any error, which means it is imported. So you can take any raster data for practice. Here I am considering one single band raster data. Any raster data you can consider. File name equal to, in inverted comma, I am writing this. Why? Here you have one more option to give complete path of the file. Right now I have given name. So this, it will, the script will look for this file inside the folder where this Jupyter notebook file is kept. So here lecture 2, since I have given name here lecture 2, this is name of our notebook file. So you can see lecture 2.ipynb, ipynb, that is extension of this notebook file. So it will search for this file inside this folder only. So if you are having data in some other folder XYZ and your notebook file is here, so in that case, need to go to that location, copy the complete path and write here. Start with R. This way you can write the complete path of the file. Since here I am considering a TIFF file kept in the same folder, so writing this complete path is not necessary. Now run this. After running, you will see a number here. How do you run? Press Ctrl plus Enter. Now this file name is assigned to this variable. Now this has to be read using GDAL. So use GDAL dot open. So open is the function inside package GDAL. So GDAL dot open. What to open? File name. File name is this variable. This will open and you need to store this in the form of a variable because this will return a data source. So I am writing here data set equal to this one. To check this, it has read or not, we write print data set. Data set is this variable. If you print here, it will show some GDAL object name. Suppose I am changing this file names a little bit. Now reading. So since I have changed this file name here, 2 is written and this file does not exist in my folder. So now if I will read it, so since file does not exist, it will not read anything. If it will not read anything, why it will not read it? It could not find the file. So it should not print the object. So now it is printing none, which means file does not exist in the folder. So there are many raster data types available. Different driver is needed for different data sets. For example, a different driver is needed to read TIFF file compared to IMG file. So let's see which driver is used to read this file. Anyway, this is TIFF file. So which driver? What is the name of the driver? To get name of the driver, right here data set. Data set is this variable where it is read. Dataset dot get driver. It has printed name of some object form. Now we'll write dot sort name. So dataset dot get driver dot sort name. It will print sort name of the driver, that is gtip, referring to reading geotip file. What is the size of this raster? X size and Y size. X size means number of columns, Y size means number of rows. Dataset dot raster X raster Y. So X size and Y size, they are 1153, 1153. Row and columns are same. Y size will give rows, X size will give columns. Use this plus to add these cells. Now let's see how many bands are present in this data. So data set dot raster count. This will give number of bands present in the data. If there is only one band, so it is showing 1. Let's see projection system of this data. Data set dot get projection. This will print the SRS information, that is WGS 84. Now what else can be seen from the raster? Its extent and pixel size. So that you have in geo transform. So data set dot get geo transform. This will give transform. Spelling check. This will give you the top left corner. This is longitude of top left corner. This is pixel size. This is latitude of top left corner. This is again pixel height. This is pixel width. This is pixel height. This 0 and 0, this is related. These are the orientation of the data. 0-degree orientation. Top left corner longitude is this one. Top left corner of the image. Have image of this kind here. So these are the pixels. The top left corner means this corner. So x coordinate means longitude of this coordinate and latitude of this coordinate are these values, longitude and latitude. Then pixel width, this is pixel width and this is pixel height. So this top left corner is considered as origin of this image. We will see what is the other advantage of this later on. Whatever things we are seeing here, these are the properties of the data set itself, not related to band. One image or one TIFF file may have n number of bands, but the pixel size, the top left corner, origin of the image, uh, rows and columns, they will be same for all the bands. So these are the properties of entire image compared to individual bands. Which are the properties of individual bands? The statistics, minimum maximum value per band, so pixel value in each band, they are related to different bands. So now we'll read data from the band. Data, first we'll get a band equal to data set dot get raster and 1. The band counting starts from 1. Now data equal to and dot read as array. This will read the data in the form of array. This is the data. So these are basically the pixel values. So these are the columns, these are the rows. So there are total 1153 rows and 1153 columns. All cannot be displayed. So few columns, then dot dot, few columns, then dot, then few rows, then dot, which means data is in between. This array is so large. Now let's verify this. What is size of this array? Expected is same as this value, raster x size and raster y size. How to check size of the array? Data dot shape. Basically name of the array dot shape. This will give shape, row and column. To get minimum value of this array, we write numpy, which is imported as np. So I am writing numpy np dot min of what? Data. Will print minimum value np dot max. So this will print maximum value, that is 122. Now let's see how to plot this. So to plot this, we need a plotting library, which is matplotlib. pyplot uh, module of this matplotlib will be used, which is imported as plt. So I will write plt dot insoup, and here you need to write name of the data which need to be displayed. This is the data lt dot color bar. This will display the color bar here. So as you can see, minimum value is 25, maximum value is 122, but most of the values are between 40 to 60, or they are below 60. That idea can be taken from this color plot. You can plot histogram also. plt dot hist. The size of this can be increased. Size of this image can also be increased by writing here lt dot figure size. Let's say I want to make pixels 10 comma 10. So here you are having this as your data. So right now you can see the markers here on x-axis and y-axis. They are starting from 0 to 100, 400, going up to 1153. They are basically the row number and column numbers, not the actual coordinate values. To get the actual coordinate values, this information has to be passed here. So to define that, we need in x comma max x comma min y comma max y. So basically, a bounding box need to be defined to plot this array on the geo coordinates. Minimum x and maximum x. What will be the minimum x? What do we know from this? We have the information from geoid transform function that is giving us the coordinates of top left, which is minimum x and maximum y. X is this one, y is this one. So what do we need? A minimum x and maximum x. So minimum x will be this coordinate, maximum x will be this coordinate. How will you get maximum x? You add number of pixels in the x value, so you will get maximum x. So number of pixel on or number of columns multiplied by size of the pixel will give you total width of the image. Number of columns multiplied by size of the pixel will give you maximum x value. The same thing will write here. So minimum x directly can be taken from this geo transform. So let's write as trans this one is what? Minimum x value. So minimum x is trans. So minimum x is trans 0. Now maximum x need to be calculated how? Pixel size into number of columns. Trans 0 plus trans 1 multiplied by trans 1. Trans is name of this geo transform output. The trans is variable which is having output from this geo transform function. So this one is trans 0, this one is 1, 2, 3, 4, 5. So one is pixel size. That's what I have written, pixel size into number of columns. So where we have number of columns, if you print data dot shape, so here this one is number of columns, this one is number of rows. Number of columns will be data dot shape 1. 1 means this index. So now you are having maximum x. Now minimum y. By the way, what is maximum y? Maximum y is already given. The y coordinate of top left corner is already given, that is this one. Trans 3, 0, 1, 2, 3. Trans 3. And how will you get minimum value? this is maximum. So to get minimum value, you need to subtract number of rows multiplied by size of the pixel. So minus number of rows multiplied by size of the pixel. Size of the pixel is in trans 1. Number of rows to multiply here, that is data dot shape 0 is the number of rows. So you got the minimum value for y. Maximum value is already. You got minimum and maximum value. After having this, the same thing you need to pass here, plt.imso data extend pass. So now you can see values has changed. Earlier pixel values were present here, pixel number was present here. Now the actual coordinate values are displayed. Along with this, you can choose CMap equal to, let's say, it will display your image in gray color. So you can search uh, details of this function in Python as well as internet to get different kind of color maps available. We have read a single band image. Now we'll read another image which is having multiple bands. For example, this image, for practice you can consider any image which is having more than one bands. Minimum 3 bands or more you can have. So this image is having 4 bands. So let's see. So what is the next step after defining file name? Dataset equal to gdal.open. It will open the dataset. Now let's see how many bands are present. Dataset bands equal to dataset dot raster count. Okay. Print bands, it will print number of bands. Now let's write code to plot each 4 bands. So for that I will define the figure size, plt.figure, fig size equal to, the fig size should be in the form of tuple. Then read the bands one by one. For I in range, we'll start this range from 1 because we know a band number is 1. Minimum value for band is 1, not 0. So counting for band starts from 1. From 1 to bands plus 1 and equal to data set. Data set is our data source which we got from gdal.open. dataset dot and I and data equal to dot read as. This will read the data, this will convert the data to array format. Now, how do we need to plot? Since it is a 4 band, so we need to divide a plot in 4 parts. That will be done using subplot function. So plt dot subplot. How many? 1 comma 4, which means 1 row and 4 column. Plot will be divided in 1 row and 4 column. And which plot will be used to plot this particular band I. So plot 1 for I1, plot 1 for I2, plot 2. Else plt dot ISO dot ISO data. Okay. Else we have got an array error. And what is the error? Uh, so that color map is used. So you can see your all 4 bands are plotted. We'll quickly see how to write this data. So to write this data, we need a file format. File format is fine. I will write gdiff we need to get the driver corresponding to this call dot get driver name. So it is having a driver to create TIFF file. St underscore file name includes destination file name. I am writing out.tiff. So I want this to be my file. What is next? Out data source need to be created. Just like we read using GDAL, we will create a data source from GDAL. How? The same method. Out ds equal to GDAL dot open. What open? dst underscore file name. So it will create a blank TIFF file. This so basically it will create a data source, not any TIFF file is created. So now we need to, sorry, my mistake. Uh, Instead of opening, we need to write gdal dot create to create the data source. Gdal dot create what to create destination dot file name dst dot file name, that is lecture 20 lecture 2 out dot is, that is file name. This will be created. What else we need to define when we are creating a new file? Basically row, column, number of bands and data type need to be defined. How do I know number of columns, how many number of columns are needed? Let's say we are having this data and I want to add 20 here and write in the output format. Data equal to data new data plus 20. Let's see, 20 I am adding to each pixel, and now this added image need to be written. To row column, how do I get? Data dot shape. This will tell me row columns. Size basically need to be defined, and y size need to be defined. What is x size? X size is number of columns, which is 209 from data.save, and y size is 460. This need to be defined. Then number of bands. How many bands? One band, if since I am writing single band image. Then data type of the file, means it is 8-bit data, float data, integer data. So if you print here, the minimum value is starting from .min, entry dot max data. Minimum value is 68 and maximum value is 245, which means it can be written as 8-bit data. For 8-bit value ranges from 0 to 255. If you are increasing the bit type size, storage size, file size will increase. That is not needed. So I will use 8-bit data here. 8-bit data type to write this band. So E type will be gdal dot gdt 8. Byte is 8-bit only. Bracket is not used. Okay. Here it is driver dot create. This driver will be used to create the file. So now if I will go here to my folder location, I will see a file named lecture 20, sorry, lecture 2.out. That file is created here, but size of this file is 1 KB, 0 KB. You will see that is very less because no data is written, only blank file is created. Now what we have to do, define its coordinate system. So for that we need OSR library to define this spatial reference system. SRS equal to OSR dot spatial. SRS object is created. Now the projection system need to be defined. Set UTM. I am setting UTM because if you will see my this source data, which is inside data set, data set, and if we will print its projection system, the original data, it is UTM zone 44 north. So that is why set zone UTM 44, 144 north is defined, because same data I am writing in different file. Basically, the projection system will not change with a simple addition of some numerical value. The data need to be graphic coordinate system. That is WGS 84 in this case. UTM zone 44 and geographic coordinate system, basically datum 1984. So that is defined here. This 0 means what else is needed. Basically, the extent of this file is needed. The minimum maximum value or the anchor point or top left corner and pixel size is needed. Right now we are having data as uh, data which is array format. If this need to be converted to image, the pixel size need to be more. So we'll get pixel size from the source data itself. That is data set dot get geo transform. So dataset dot get geo transform. This is giving the x coordinate of top left pixel size, y coordinate of top left pixel size, its orientation. Basically, same geo transform can be used for this. What I will write here, uh, out ds output data source geo transform. Now I am setting the values from get geo transform, that will be written here as set geo transform. Now till now projection is defined. This projection is defined. This has to be set for our output data set, which is having name outds dot set and that is SRS. The object name is SRS dot KT. SRS dot export to WKT will export to this format, the projection system format. So if we are doing this, we got some error. And what is that error? Export to WKT, no error. After till now, what we have done, we have defined a data source, we have defined a projection system, its extent, everything is just defined. Now data has to be written. So how do we write the data? The way we read it. We have read band by band. We need a band to read the data. Here we need a band to write the data. Out band equal to out ds dot get faster band 1. So now in this band we need to write the data. How? Out band dot write array. Now data is written. But still, if you go to your location, you will see that size of the file has not changed because we have not closed this data source. The size will change once we close the data source. So how do we close? It's very simple. Name of data source equal to none. So it should write the data. Now data writing process is completed. Maybe because of very less size. Here size is not changed. I will see. Now we'll see how to read a shape file. It will take very less time. We need a GeoPandas library. There are many libraries available like OGR is also there, Shapely is there, but we'll go for GeoPandas. It is easier to learn and implement. We'll import GeoPandas as GPT. I have the library installed. It will import it. I have a file named notes.shp. You can use any point file to complete this exercise. I am writing a variable name locations. How will I read gpd dot read underscore file? This is the function name and pass here name of the save file. It will read. So we need to pass in inverted comma. Now let's see what it is giving in return. Type. It is a geodata frame. How it looks like. It is having uh, only four features I will display also. So this shape file is having 4 points. Those 4 points are displayed here. In QGIS, if you'll open its attribute table, you will see ID field is blank, class field is having class names for these 4 points. So those 4 points class names are written here, ID is blank, and there is another field coming here, geometry, that is hidden from in the software. So geometry field you will not see in QGIS, but here you will see geometry field. Why? Because this is spatial data, it is having geometry associated with it, and kind of geometry here is point geometry. So point you will see, then its coordinates, point and its coordinate, basically longitude and latitude, you will see here. If it is a line file, so line is made by connecting points or vertices. So you will have a series of points for line. If it is polygon, you will get geometry type polygon, and a series of points will be listed here. Those points are used to make the polygon. Got it? Distance dot plot. Uh, Name of the table is location. So if you will write here location dot plot, it will plot it. If you feel the size is smaller, you can adjust the size. X1 dot subplot size equal to, and here we need to pass this AX1. So this axis you need to pass here, and you will see size has changed. Now coordinates are not overlapping. These files belong to same area and coordinate system is also same. Let's see location dot crs. क्या है? हाँ, so here if you see the CRS, here it is UTM zone 44 north and WGS 84. Here also the same thing. They belong to same area. Now let's see by plotting them one over other what can be done. UNT.INSO data and what, if I am doing this, the thing will come here. if I am doing this, we will see two different plots. So this is supposed to plot both figures in same, but this is not happening because if you see the axis of coordinates basically of the vector file or point file, they are very large values, they are basically geo coordinates, and here we are having only row and column numbers. So first of all we need to get rid of this row and column. How? We need to define this minimum and maximum value. Basically this need to be defined. How? The same way we have defined here. So I'm running this again, those things are defined. Now we'll copy this. If you run here, so the original value of coordinate it has considered, and we can see the points are displayed over the raster image. Let's see how it looks in QGIS. 1 point here, one here, one here. The same kind of it is same. Basically we have considered geo coordinates, so we are able to display over here. So with this I will end the class, and you can try one task to get the pixel values corresponding to these points. So we are having one raster image in background. You try to get pixel value, you try to write a code to get pixel value corresponding to these points. So that you can try yourself. You need to write a function to extract values, then you need to use apply function of data frame to fill those values in the data frame. After that, when you have filled the values, you need to save this file. Saving is very easy for this save file. You need to write since this is locations, locations to save file, to underscore file, not save file, and in bracket we pass name of the file it will write. For reading, read underscore file, for saving to underscore file. So now we can have some questions.